Hello all my dear students, I welcome to Chandu biology classes. So I hope your preparation is going well for IIT JAM Biotechnology, and we are also covering chemistry part which is included in your IIT JAM Biotechnology syllabus right now. So here we already discussed about structure of atom like Bohr's model, which is specially mentioned in the syllabus. Okay, along with that we have some questions based on these quantum numbers, asking about number of radial nodes, angular nodes, or something related to these quantum numbers. Okay, so we need to have some clear cut idea on these quantum numbers so that we can answer any question that comes from this quantum related topic, quantum numbers related topic. See, first of all I will show you what kind of questions that are appeared in the previous year papers, so that you will get some clarity over this topic first. See here, see, look at here, total number of nodes for a quantum number, giving some quantum numbers, they are asking how many number of nodes are there. They are asking like this. See, this is IIT JAM BT 2011 question. Okay, and also similar to that we have one more question here. See here, atomic orbital has two radial nodes and one angular node. So which atomic orbital it is? So this is also one question asked based on what? See, this is a 2014 question. See, based on what? Quantum numbers only now. Yeah, again see, this question is from Bohr's model. We have discussed what kind of lines will be appearing, spectral lines. So tell me, so what are the lines we have? Lyman series, Balmer series, Paschen, bracket, like this now. So any 11th to 4th level means what spectral line it is? We discussed in the last class. See, Lyman. So what is the lowest one? N value equals to 1 means it is Lyman. Then next n equals to 2, Balmer, and n equals to 3, Paschen, n equals to 4, bracket. So from any higher energy level to 4th level they are saying, any higher energy state to 4th level. So that line corresponds to which one? That line corresponds to bracket. What is that? Bracket. Okay, so your option number 4 will be correct. See, for this kind of question you no need to spend any time and no energy is wasted here. Just by looking at the question you can answer without wasting any time right now. So you should not skip this kind of topic. See again what kind of questions we have in this. These are the questions on Bohr model, and this is a question on radial nodes and angular nodes. Okay, so now I will be making you to feel clear with these quantum numbers in this particular session. Okay, so what exactly quantum numbers first? See, what exactly quantum numbers? See, this is a quantum mechanical model of the atoms like electrons. So finding electron. For example, if I want to give an address of a particular person, something like a person from, let us say we are discussing about this Chandu biology classes, which is located in Hyderabad, and I am your teacher here right now. So if I want to express my address, someone should say like this. So he belongs to India and Telangana, Hyderabad, and Narayanguda Chandu biology classes, something like this. Exactly everything should be mentioned so that you will get exact address of mine right now. Similar to this, if we want to express the address of an electron, exact position like where electron is present, if we want to express that, so these quantum numbers are used for that purpose. Okay, to express the exact location or the finding the electron, region of finding an electron will be expressed using these quantum numbers. So how we got this quantum number? See, Schrodinger wave equation is there. For example, see, we know we are representing wave as like this right now, something like this. Okay, so let us represent psi is a wave function. See, greater the amplitude, what does it mean? So greater is the probability of finding electron in that region, you can understand. Okay, so now this is a wave function. So finding the Schrodinger wave equation for hydrogen atom, we will get a solution of this wave function. So what is the Schrodinger wave equation? There are two things. They may ask direct question from this, what is the Schrodinger equation from the 4 options. So there are two ways I can express. One is H psi equals to E psi. This is one Schrodinger equation. Okay, this is reduced one, and one more is I can express like this: del square psi plus 8 pi square m by h square E minus v psi equals to 0. So this is normal expanded form. Both are Schrodinger wave equations. Okay, so now by solving this Schrodinger wave equation for hydrogen atom, see in the exam you won't be looking it like this. This del is there now, so this del square will be represented like this. So it is a Laplacian operator, so it will be represented like partial differentiation, dou square by dou x square psi, represents psi, plus dou square by dou y square psi, again dou square by dou z square psi, plus like this del refers to this dou square by dou x square, x coordinate, y z coordinates, like that. Okay, and the next 8 pi square m by h square E minus V psi equals to 0. What is this? E is the total energy, V is the potential energy. Okay, so they do not ask how to solve Schrodinger wave equation for hydrogen atom and all, but upon solving, what we got for hydrogen atom, if we solve, we got some numbers, those are like N, L, Ml. So what is this N, L, Ml? So N is called principal quantum number and L is called angular or azimuthal quantum number, and this one is called Ml is called magnetic quantum number. Okay, so these are the three quantum numbers obtained from where? By solving Schrodinger wave equation for hydrogen atom or something like that. Okay, so now we will be discussing about this. So what it is? Quantum numbers means it is a set of 4 numbers required to define an electron in an atom completely. Okay, so what are those 4? Principal and the next azimuthal, magnetic, quantum number. See, first 3 came from Schrodinger wave equation. Okay, and this 4th quantum number is not from Schrodinger wave equation. It is added externally it is added. Only first 3 are from solving Schrodinger wave equation. Okay, see. So now we will study one by one. So what exactly principal quantum number? It is indicated with a symbol N. Okay, so here it tells about the energy of the shell in which electron is present or the size of that shell, like radius we are saying now. So just give me a recap of what we discussed in Bohr's atomic model. How can we find energy? So you are saying now minus 13.6. Next Z square by N square electron volt per atom. We discussed in now. See, N value, this is N is nothing but principal quantum number only. Okay, so N tells about energy of shell. Yes or no? So here N is deciding what is the energy of that particular electron. Okay, and next what about radius formula? So you should keep in your mind all the time 0.529 N square by Z. Okay, this is in angstroms. See, again radius, it means size of the electron in which that like whatever the shell is there now, the radius of that shell in which electron is present is also defined by this principal quantum number. This should be remembered. Okay, so now for example we know we will be filling electrons in hydrogen, like electrons in the atoms like 1s orbital, 2s orbital, something like this, 2p orbital, like this now. Okay, so now what is the energy order for them? They will ask, like see, by giving some different set of orbitals like 1s, 2s subshells, 1s, 2s, 2p we have, next 3s, 3p, 3d, 4s, something like this they will give, and they will ask arrange them in the increasing order of their energies. So how do you answer for this? Okay, so whenever they ask for increasing order of energy, look at here. So for single electron systems you have different order, multi electron. So 2 things are there. One is single electron, examples like hydrogen atom or helium ion or lithium plus 2 ion or beryllium plus 3 ion, like this. And one more is multi electron system. So what is this single electron? Only 1 electron should present. In that case, the energy levels of these subshells or these orbitals will be decided only by N value. Single electron system energy depends on what? N value. Energy depends on only N value. So what is N here? Principal quantum number. So higher the N value, higher is the energy. Okay, higher the N value, higher is the energy. Just now I given a formula, E is equals to minus 13.6 Z square by N square. See, minus is there and this is in denominator. this is greater value, so overall less negative, it means towards the 0, it means maximum energy. So higher the n value, greater is the energy. Okay, so now in this case you tell me which is having higher energy. 4s is having higher energy. Next 3d 3p will be having, 3s will be having same energies, because this I am talking for single electron system, very important, single electron system. Okay, so these have equal energies now. Okay, what about this? Here again equal, again greater. So now see, wherever you are seeing with equal energy, those are called degenerate states. Degenerate states. How many degenerate orbitals are there? Okay, so here now I will be giving you one just direct formula for single electron system. Number of degenerate orbitals in an nth level. It means some n value is 2. How many degenerate orbitals are there in that nth level? I am not saying shells, subshells, I am saying orbitals. See, it is equals to n square. Use this formula just. See, let us say for second energy level, how many orbitals are there? 2 square, that will be 4. So what are the 4 orbitals? 2s orbital is 1 and 2px, 2py, 2pz, like this. Is that clear? Okay, you should not say only 1p orbital. This is 1p subshell. This is it's a subshell. In that subshell we have like here p now, so 3 orbitals are there. So we already discussed shells, subshells, orbitals, in that electrons. Once again, shells, subshells, orbital, electrons. Okay, so in s subshell how many orbitals? 1 orbital. In p subshell we have 4 orbitals. In p subshell, px, py, pz, 3 orbitals. Okay, just remember odd numbers. S1, P3, D5, SF 7, like that. If there is something like G 9, like that. Okay, so 1, 3, 5, 7, like that, you just remember. Okay, now is that clear? So for example, in third energy level, how many degenerate orbitals are there for single electron system? Orbitals.
3 square
9. So what are those 9? 1 3s, here 1 and 3 p's and 5 d's. Okay, total 9. Is that clear? Yeah, that is very important. And maximum electrons that can be filled in these degenerate orbitals. See, in one orbital, how many electrons we can fill in one orbital? So it will be always 2. If they mention orbital, your answer should be 2. Okay, so if they mention maximum number of electrons that can be filled in the nth level of let us say third level, how many? 18. So each orbital 2, so 2 into 9 are there, so 18, like that. 2n square. What is the formula here? If they ask for electron, just take it as 2n square, that's it. Okay, so this story is for single electron. Now I am asking for multi-electron. So in the multi-electron, the scenario will be changes. So in case of multi-electron system, energy depends on both, depends upon n plus L value. Higher the n plus L value,
higher will be the
energy. Okay, if n plus L value same, then consider n value. Okay, so first depends upon n plus L value. This is first thing. And second thing, what I am saying, if n plus L value is same, consider only higher n value, higher will be the energy. Okay, these two things are very important to deciding the energy levels. Okay, hope it is clear. Now what is L here?
L is
Azimuthal quantum number that we are going to discuss now. Okay, yeah. So look at here, azimuthal quantum number indicated with symbol L. Okay, this is also called as subsidiary quantum number. Okay, so here what it is giving us, so it says about, see this quantum number tells about number of subshells in an energy level or in a shell, number of subshells in a shell. Okay, so now number of subshells in a shell is given by L. Okay, so for a subshell, first subshell, n value will be 1. So always remember, for a n value, L will be always lesser than n. Always L should be lesser than
1
n. So if n is 1, L should be 0. If n is 2, L can be 0 comma 1. Okay, like that. Okay, now if L value equals to 0, if we have, so what we are saying, L says about subshells, I am saying now. So if L equals to 0, you can say this is S subshell. What is that?
It is S subshell.
If it is 1, P. If it is 2,
D subshell.
D. 3,
F subshell.
F sub. Very, this is also very important to decide. Okay, so angular momentum of electron present in the subshell, it also says angular momentum. Okay, so here angular momentum like angular momentum I am indicating like this. This is, take it as formula L into L plus 1 h by 2 pi. Okay, so now sometimes in the question they may also mention h by 2 pi is there now, this h by 2 pi. This is also given as this hash, h cut, I can say h cut or hash is nothing but h by 2 pi. This can be represented like h cut. Okay, next, shape of various subshells present within the same shell. So S subshell will be having spherical shell, sphericals like that. P will be having dumbbell. That is also explained by this azimuthal quantum number. Okay, so relative energies of various subshells. Okay, so what I told you, for multi-electron system, energy depends on n plus L value I told you. So now decide the order. Yeah, so now decide for 1s, 2s, 2p, 3s, 3p, 3d, like this I have. So now decide their energies. How do you decide?
Depends on n plus L.
So what is the, here let us come from here, n value is 3. For d orbital, what is the L? 2. So take it like this. Again here
3 plus
1. For P 1 na, so 4. Here
3 plus 0 sir.
4, 3. Next here
3 plus 1 sir.
2 plus
1 sir.
3 here. Here
2 plus 0 sir. Again 1 plus 0.
1. So now here which is having highest n plus L?
3D.
That will be higher in energy. Now here again 3p. Now in this case n plus L is same, but n value here is greater than here right now. So if n plus L is same, consider n value. So therefore it will be higher energy. And here like this. Okay, hope this is clear. Yeah. So again, number of orbitals in a subshell, if they ask, in a subshell. So how do you take number of orbitals in a subshell? Take just 2L plus 1. Okay. For example, S subshell, what is the L value?
L value is 0 sir.
So 2, 0 plus 1. So it will be 1. For S subshell, L is 0. So number of orbitals will be 1. For P,
2 into 1 sir.
2 into 1 plus 1. So 3 p orbitals. Next for D,
2 into 2 plus 1 sir.
5. Like that. We already discussed 1, 3, 5. Just remember odd numbers I told you. Okay. Next. This is about principal like azimuthal quantum number. Next we have magnetic quantum number indicated with M or ML. Okay. For a particular L value, this azimuthal quantum number ML values lies from minus L to plus L. Okay, so this says about orientation of orbitals. Okay, so for example, I have L equals to 1. So ML will be -1, 0, +1. Right now, so if L is 1 means which subshell it is?
L1 P sir.
P subshell. Right now, so P subshell has how many magnetic quantum numbers? 3. So that's why we are taking 3 orbitals now like this. So like -1, 0, +1 you can consider. Okay, so here is a subshell, L will be 0, ML value also 0, so number of orbitals are 1. Okay, so for a given subshell, if they ask number of magnetic quantum numbers, you can also use this formula 2L plus 1. Okay, right. Next one is spin quantum number indicated with S or MS. Okay, so what it says? It says about electron spin. What is that? Electron spin. Spin of electron can be either clockwise or anti-clockwise. So if you are representing one direction clockwise with +½ and anti-clock you can represent with -½ or vice versa, no issues anyway. Okay, so now but both electrons should have opposite spin. Okay, so now so in an orbital how many electrons we are filling? That rules are there, not 2. So both electrons should be with opposite spin. Okay, this rule is what? Pauli's exclusion principle. Okay, we will discuss after this. See here, for example, I have d5 electronic configuration. Okay, so how many d orbitals are there? 3d, 5 means like d5 means how many d orbitals? 5 d orbitals are there. How many electrons I mentioned here? So now by following Hund's rule, now I am saying 3 rules. What are those? One is Hund's rule, another one is Hofbauer principle, another one is Pauli's exclusion principle. Now what is this Hofbauer principle? What is this Hofbauer principle? Whenever you are filling electrons while writing electronic configuration, always fill electrons in lower energy first, energy first. Okay, it means just now we have discussed now. So one is like I have 1s, 2s, 2p, 3s I have something like this. Lower energy is which one? 1s. So first fill the electrons in this. Okay, how many orbitals here we have? 1 orbital. So first fill the 2 electrons in this. After this go to the next higher energy level. Again 2 electrons will be filled here. Next here 2p are 3 orbitals are there. Okay, so whenever we have like 3 orbitals, here 2 orbitals on like 1 orbital, no issues. But here we have 3 p orbitals now like this. So now you need to fill the electrons by following what is it? Hofbauer principle is over now. Hund's rule and Pauli's exclusion principle. What is this Hund's rule or so electron should be filled with a maximum multiplicity. It means if we have some 3 electrons, so you should fill 1 electron here, another electron here, 1 electron in each of them. So how many we got? 3. So what is this maximum multiplicity? See, you just find a multiplicity formula like 2s into 2s plus 1. Okay, so what is the spin value here you got? Each one with half. How many electrons? 3 electrons. So each electron with half, so 3 electrons, so 3 halves. So 2 into 3 by 2 plus 1 like this. Okay, 2s plus 1 you can say. Okay, so now that value should be greater 1, I am saying. Next, if I have P4, how should I fill?
P orbital, we have 3 orbitals.
So first fill 1 electron each, then the 4th electron will be goes here with the opposite spin. That opposite spin is given by Pauli's exclusion principle. What he says? No 2 electrons in an orbital should contain same spin. They should have opposite spin. Okay, yeah. And one more rule he can also say that no 2 electrons in an atom should have all 4 same quantum numbers. It means there should be some difference in their quantum numbers. That's why electron spin is differ here. Okay, so now so we'll solve some questions on this, no issues. Tell me here how many 5 now? So 1, 2, 3, 4, 5 electrons like this. So total spin how much it is? 5 electrons, 5 by 2. Okay, so now they will ask you what is the magnetic moment, spin only magnetic moment. You just use root over s into s plus 1, or you can use this formula other ways. Just take number of unpaired electrons, n into n plus 2 Bohr magnetons. What is that? N into n plus 2 Bohr magnetons. So n represents number of unpaired electrons. How many unpaired electrons are there here? 5. So use that 5 here. So 5 into 5 plus 2, 7. Okay, I can write here 35. So this will be near to root 36 is 6. So this will be around 5.83 Bohr magnetons like that. Okay, yeah. So you got how to find spin magnetic moment. So this will be for if any unpaired electrons are there, we are saying it as paramagnetic. If all electrons paired, diamagnetic. Okay, magnetic moment is available or applicable only in case of, this formula is applicable only in case of paramagnetic substance. Okay, done. Okay, again, if we place a paramagnetic substance in the external magnetic field, what happens to that?
It will get
Attracted towards the external magnetic field. If I place diamagnetic one, it will repelled, weakly repelled from that external magnetic field. Next, yes. So I have few questions here. So first we'll solve. Okay, you just tell me which are the following set of quantum numbers is not allowed. Identify.
n is equals to 3, l is equals to 2, ml is equals to
If n equals to 3,
sir,
L should be always less than L. So it should be 2. It can be 2 here, and ml value can lies from minus L to plus L. So minus 2 plus minus 2 minus 1 0 plus 1 plus 2. Okay, minus 1 is possible here. This is correct only. They are asking not allowed. Yes, tell me which is not allowed. Easily. Here it is visible. Third option. Yeah. See, n equals to 3. L.
less than 2.
Yeah, but it is equal. So L should not be equals to. This is incorrect. So you can choose this, which is not allowed. Okay. So now we'll see the questions from biotechnology here. Yeah. This one. Tell me. Here, an atomic orbital has 2 radial nodes and 1 angular node. So what actually this nodes? See, how to find this? Radial node is equals to, you just use this formula, n minus L minus 1. N is principal quantum number and L is azimuthal quantum number. Okay, and then next, angular nodes, if they ask n angular nodes, just that is equals to its angular like azimuthal quantum number L. If I say total nodes, these are the sum nodes, just sum them. Radial nodes is n minus L minus 1, angular nodes is L. So total nodes n minus 1. Okay, these 3 formulas are again important. Okay, now tell me, atomic orbital has 2 radial nodes and 1 angular node, then it is a 2 radial nodes. So for P, just identify, try to identify, n value is 2, L value is 1. Okay, then radial nodes will be how many?
n minus L minus.
So 2 minus 1 minus 1, it should be 0. Okay, they are saying 2 radial nodes it should be. Okay, so let us consider this example. So 3 minus 1 minus 1, how many? 1. They are saying 2. This is also incorrect. Go for this.
3.
N is 3. L for D is
5.
L.
3 minus 1 sir, 2 sir.
L value is
2 sir.
2. Next,
1, sir.
this is 0. And for this,
4 P sir.
4 minus
P 4 minus 3 sir.
4 minus 1, L value is n minus L minus 1. N is 4 for P here, coefficient. So angular momentum is how much? Azimuthal quantum number for L is how much? S is 0. For P we are saying 1 L value. For D we are saying 2 like this now. So what is the L value for P?
1 sir.
1. Okay,
Minus.
and minus 1. So it will be
2 sir.
2. So 2 radial nodes we got in this case. Okay, angular nodes how many I told you?
1 sir. It should be equal to L.
So what is its L value? For
One.
P, L value is 1. So angular nodes are 1 here. Okay, they are also saying 1. So our answer is
4 3
4. Very easy only, no? Yeah. Next. So try this question. So what is the answer? Difference in the number of nodes for quantum numbers. Number of nodes they are saying. It means they are not saying radial nodes or angular nodes. It means total nodes you can take. What is the formula of total nodes?
Angular nodes plus radial nodes sir.
How much?
N minus 1 sir.
N minus 1. So n minus 1 you can use.
Yes sir.
Total nodes n minus 1. So how much?
3 sir.
4 minus 1 3 here. Okay, and for this
2 0 sir.
0. So they are saying the difference.
3 minus 0 is
3 minus 0 will be
3 sir.
3 only. So your answer should be easy only. Yeah. Now we already solved this question for related to Bohr's atomic radius. Okay, what is the formula we should use? Radius. See what they are saying. First Bohr's stationary orbit of hydrogen atom is this much. Okay, R1 is 0.53 they are saying. So what is the formula? Rn equals to 0.53, 529 or 53 you can take, n square by z angstroms. Okay, so now for first means this both will become atomic number 1 only, n value also 1 only. So it will be this much. So they are saying radius of second. So just take here value
2 sir.
2. So it means multiply the 2 square means
4.
4. So just multiply this, you will get this as your answer. We did this in the last discussion also. Okay, yeah. Next. Do you remember we have discussed this in the last class, Lyman series?
Yes.
Now they will ask number of spectral lines possible when an electron de-excites or falls from nth level to ground state. For example, nth level means 5th state to ground state. Ground state means n value is 1. So how many spectral lines are possible in this case? Tell me. From 5th level to first level when an electron is falling, how many lines are possible?
5 to 1 sir, 4 to 1, 3 to 1, 2 to 1.
Like that, how many are possible total?
Only 4 sir.
No. See, from 5th state to, from this 5th state we have electron. So it can directly come to first state. 1, 2, 3, 4. Only 4 levels I have taken. So 5 we require. I will draw a line here. Separately I will take 1, 2, 3, 4, 5. Okay. So n equals to 5 to 1. This is 2, 3, 4. Let us say. Okay. So directly 5 to 1.
Yes sir.
So directly 5 to 1 it can be. Okay. Or 5 to 4 it can come. Again 4 to 1 it can be. Okay. Or 5 to 3 it can come. From 3 to 2 it can come. Again 2 to 1 already written. Okay. Or directly from 3 to 1 it can come. Or 5 to 4. Okay. And 4 to directly 1. Or 4 to 3, 3 to 2, 2 to 1. Okay. Directly from 3 to 1 also already written. Okay. Any other possibility? Just check.
No sir.
See 521, 524 is there, okay, 523 is written, so next 322, yeah, so just count number of lines we got.
9, sir.
9, so one more line we are missing then. So I will tell you what is the formula here. So number of spectral lines here, just use this formula. See, writing like this will be making you like taking time now. So just take n2 minus n1, okay, into n2 minus n1 plus 1. Use this formula, you will get number of spectral lines. Okay, if it is not clear, so again we will try this after doing this 1 by 2. So 5 minus 1, 4 into
4 plus 1, 5.
See here 5 minus 1 plus 1. So I can remove this. So how much here?
4, 5, 2.
So 10 lines we should get. Okay, so just check here. 5 to 1, next 5 to 2, next 5 to 3 and 5 to 4. Okay, so next 4 to 3, 4 to 2. Where is 4 to 2 line? Yes, that is what we are missing. Okay, like this. So now just count the number of lines 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are the 10 lines. Okay, now they will may ask how many lines falls in Balmer series. How many lines falls in Balmer series?
3, sir.
What are those? See, Balmer series means this one, second level. Okay, so this line, this line, this line, 3. Like this also they may ask, you should able to identify that. Okay, now how many lines falls in Lyman series?
1, 2, 4, 7.
So here also I will give you one simple formula. So number of lines falls in Lyman. Just use n minus. Lyman means from any level to first level. N minus 1 you use. Okay, how much? 5 minus 1. So it is 4 na, see 1, 2, 3, 4 lines working. Okay, number of lines in Balmer?
N minus 2, sir.
2, 3 are there now, so n minus 2. Number of lines in Paston?
N minus 3, it will be 3, sir.
It should be 5 minus, Paston means n3 na, n minus 3. So 2 lines, so this is one line, second line working, so you can use that formula. Okay, next. Yeah, so this question only we have solved. Maximum number of spectral lines appears in. So now tell me, from maximum number of lines possible when an electron falls from 5th state to first excited state. What is the first excited state? If I say ground state, n equals to 1. Say first excited state means first excited state means what? Ground state means n equals to 1. Lowest energy state is ground state, and the next higher state is n equals to 2, n equals to 1. This is GS, ground state. The next higher energy state is first excited state. So its n value is 2. So it means electron is falling from 5th level to second energy level. So n value is 2. So you can use that 1/2 into n2 minus n1, that is 3 here, 5 minus 2 again.
N2 minus N1 minus plus 1, sir.
So how much? 5 minus 2 plus 1. So it is
4, sir. 12.
So here 4. So it will be
6, sir.
6 lines. Okay, like this you should do. Okay, next. And other questions related to quantum number. Yes, look at here. So 3pz has what? See, I suggest you, if you want to solve more questions related to chemistry, okay, so you can refer the material of this Chandu biology class, one thing that is, and the next thing is you can also see CUET paper questions, I mean chapter wise questions of CUET from this chapter wise, like structure of atom we are doing, you can do that, and also IIT JAM questions of chemistry. Okay, these are the things you can follow. Anyways, IIT JAM questions are little bit tougher when I compare with IIT JAM biotechnology with IIT JAM chemistry. Okay, but you can just try whatever the possible questions you have. Yes, answer this question. So 3pz, n is 3,
L is 2, sir.
L value for p will be
P 1,
1. So radial nodes are how many?
radial nodes, sir. N minus L, sir.
N minus
L
L minus
1.
1. Okay, so 3 minus 1 minus 1. So it will be 1. Radial nodes are 1. Okay, and angular nodes are directly I told you directly equals to L. So angular nodes are 1. So one radial node and one angular node for this 3pz orbital has. So what is the suitable answer?
1 radial node, 1 A and C, sir.
So this is multi-selective MSQ type question. So A, C are the answers. Okay. Yes. Yeah. So try to identify these.
Two set of quantum numbers with same number of radial nodes.
Two set of quantum numbers with the same number of radial nodes.
3 minus L minus 1. It is 3, sir. 3 minus.
See, they have given one set and the second set is given in each option. So they should contain same number of radial nodes. So easy to identify. Just check.
First A row, first it is 2, sir.
N minus L is minus 1, that is 3 minus 0 minus 1 is 2. In this case 2 minus 0 minus 1, this is 1, this is not equal, remove this. Next option 3 minus 1 minus 1, so 1 again, and here in this case 2 minus L is 1 again, so 0, this is also incorrect. Next option
3 minus 2 minus
3 minus 2 minus 1, 0 radial nodes, and from here
2 minus 1 minus 1.
2 minus 1 minus 1, here also 0. So your appropriate answer will be C. Next check for this D.
3 minus
1 minus 1. So
minus 1, sir.
1 here, and this case
2 minus 1 minus 1 is 0, sir.
so 0. This is also incorrect. So only option C is perfect answer for this question. Clear now?
Yes, sir.
Yeah. Next. Yeah. So try to solve this question. The quantum numbers of 4 electrons are given. Yeah, the correct decreasing order of energies of these electrons is. How do you find energies? I told you.
N minus L, sir.
Energy will be depends on.
N minus.
I told you for single electron
Single electron is
only n value. For multi electron n plus L value. Do you remember or not? Yeah. So tell me.
4 plus 2 is 6, 3 plus 2, 4
Huh.
plus
Here just take this 2. So 6.
5,
So it is 5. Here it is
5, sir.
it is 5. And here
4, sir.
so correct decreasing order of energy. Which is having highest?
1, sir.
1 is greater
3, sir.
then
3, sir.
3. Both are equal. Now consider
N value.
higher n value. So 1, 3,
2,
2.
4, sir.
Next
4, sir.
1, 3, 2, 4. So where we have that one? 1, 3, 2, 4 is your answer. Right? Yeah. Next. So answer this. Four D, 5P, 5F, 6P are given. Arrange them in the decreasing order. What are the things you should consider?
N and L values.
That's it. Yeah, tell me now. So tell me. So for 4D, n is 4 plus
4 plus 2, sir.
4 plus 2. So 6 it is.
Yes, sir.
Here
5 plus 1, sir.
5 plus 1, 6 here also. Here
5
5
plus 3,
plus 3,
8, sir.
8 for this, and this 6 plus 1, 7. So which is highest one?
5F, sir.
So higher N plus L value for 5F,
5F,
so higher energy.
6P, sir.
6P, next
5,
both of same N plus L value but higher N value here,
5P.
so 5P. Least is 4P. So where do we have?
5F, 60, 5P, 40, sir. First option.
First option. So that will be your answer. Next. Which of the following series of transition in the hydrogen spectrum falls in visible? Do you remember this?
Visible line, Palmer, sir.
Visible. See, first UV,
UV,
visible.
yes, sir.
Next,
Near infrared,
IR, completely near IR, far IR, mid IR, these things discussed. So UV for Lyman, visible for Balmer. Okay, remaining Passon, bracket, all this comes under
IR.
IR. So visible region is for Balmer. That's it. Okay, yeah. So this is about the session about quantum numbers, and if you have any doubts you can ask me now. If no doubts, we will continue with chemical bonding in the upcoming sessions.
Yes, sir.
Okay, so thank you for watching. So stay connected with us. If you haven't subscribed the channel yet, so please click on the like button and subscribe button so that you will get daily updates. So thank you for watching.